for this challenger number 9, a random variable x is the following probability distribution. Find the probability distribution of y equal x squared minus 2 times x. So what we're going to do is we're going to make this little table. And right now we have 0, 1, 2, 3. But for this new y, if x is 0, what is 0 squared minus 0? What's 0 squared minus 0? 0, right? And so that is a probability of 1/6. So one more time, y is equal to x squared minus 2x. If we have 0, you're going to get 2 times 0. Let's do the next one. Let's put in a 1. What is 1 squared minus 2 times 1? What is that? Ugh. Do you see a negative 1 up here? No, so we can't use that. Okay, let's go to 2. Put a 2 in. What is 2 squared minus 2 times 2? 0. So we get a 0 again. And this one was, oh yeah, this was 1/2. This was 1/5. And then for the 3, you get y is equal to 3 squared minus 2 times 3. That's 9 minus 6, 3. So this is going to be 3, and that's going to be 2/15. Okay. Now, when you look at the probability of 0, what do you get for this one? Probability that y equals 0. Normally 0 was 1/6, but here when we convert these, this is also going to be 1/5, isn't it? So you're going to go 1/6 plus 1/5. And that's going to be 11/30, I think. Turn to your neighbor, see if you can figure out p of y is less than 3. See if you can. So one more time, what's happening here is 0 for x gives me 1/6. But when I put a 0 in for y, the new identity of y is 0. Still 1/6. For 1, the probability is 1/2. But the new identity of y isn't 1/2 anymore. That the y is going to be -1. And then 2 becomes 0, 3 stays 3. And you keep the probabilities where they are, but you're adjusting what the label for y is. So now when we went y equals 0, we put those two zeros together to get 11/30. What happens when you go less than 3? What are you going to get? 13/15. Yeah. Is that easy? Yeah, it's easy. Probability that y is less than 3 is going to be equal to 1 minus 2/15, or 13/15. How about y is greater than 1? What's that going to be? 2/15. How about y is greater than -1? Half. Easy? Seem okay? Great.